Alice, very excited to talk to you. We'll be getting into your episode of Pole to Pole with Will Smith on National Geographic, where you take him to the North Pole to collect samples under the ice. But before
Yes.
that, here at Bionic Buzz, we're all about people's passions. I want to know where your passion to be a
Ah,
scientist came from growing up in Rhode Island that led you this amazing
oh,
journey.
yeah, that's a great question. So I always liked science and I was good at it. So that combination worked well for me, right? Because when you're a little kid, I think the thing is, if you are good at something, it's just immediately rewarding. So you're like, oh, I like this. And it's interesting. And it sort of fed into like my desire to always be asking questions. It's like, oh, this is a place where I can do this. Sciencing is a way in which I can just like ask questions and it's not annoying. I mean, I guess it could be a little annoying, but um, I grew up in Rhode Island. I would say that there are a few places in Rhode Island that are further than 25 minutes from saltwater. It's hard. It would be hard to still be in Rhode Island and say that you're more than 25 minutes from some salty part of the ocean. And for me, that means that I really grew up less than 10 minutes away from being near the ocean. And I loved it, right? So it's so like growing up in Rhode Island and being in a place where the culture is kind of stems from this coastal livelihood. Even if you're
Mhm.
not, even if you're not a person that works in that industry, even if your parents aren't necessarily like taking you sailing, I still was very much intrigued by the fact that I was living close to it. And I didn't realize that that was a luxury. Like, I didn't realize that that was a privilege until I was much, much older and left Rhode Island and moved and lived in other places. But I figured out very quickly that you could do science about the ocean. And that to me was amazing because I thought that the best thing to do would be to never have to like get away from the ocean. So always find a way to be close to the ocean. And then coupling that with my interest in science, I was like, oh, this can be like a thing you do for like work. Like people would pay you to ask questions and to study the ocean and to study things that live in the ocean and to study how the ocean works. This is fantastic. So yeah, so that was one of the things. And I had early exposure when I was a kid. It was all recreational. But then when I was in high school, there was a program that allowed me to do like intensive studies outside of the classroom, which is quite geeky. But I was like, hells yes, I definitely want to do this. Most of the friends that I had would go into medical offices because they wanted to be nurses or doctors. And I
Mhm.
was hoping that they had a different option for me. And so they partnered me with a group that worked at the University of Rhode Island, and they worked in fisheries and aquaculture. And I got to be like in a lab setting, and I met graduate students and researchers who were actively working on issues in Rhode Island. So we were working on lobsters. And so that was like kind of my real foray into something that was systematically ocean science.
I love that. Well, the adventure of the episode is getting Will Smith to literally the North Pole so he can complete his pole to pole journey. The heart of the mission is collecting, I hope get this right,
Oh, phytoplankton.
phytoplankton. Yeah.
Yes.
Can you explain what phytoplankton are and why they're so important to the health of our planet?
Oh my goodness. Phytoplankton are amazing. They're these incredible organisms. It's a catch-all term for these single cell organisms that live in the ocean. They also live in freshwater bodies, but in this case, they live in the ocean and they basically act as the forests of the sea. They're photosynthesizing. And what that means is just like trees on terrestrial ecosystems, they're utilizing sunlight, capturing carbon dioxide, and producing oxygen and food for the rest of the food web, for the rest of the ecosystem. And so
Mhm.
phytoplankton all across our world's oceans are generating 50% of the oxygen that we breathe. So they're generating every other breath that we breathe, if you can like fathom that. So they're highly critical to our planet and all other living organisms, including us. And the point of going to the North Pole in the Arctic Ocean to collect them in these particular environments or habitats known as sea ice ridges is that we've known for a while that sea ice ridges could be important habitats and house special types of phytoplankton or sea ice algae, and that they have evolved to be very, very sensitive to light, very low levels of light, and to be very productive. And so we're adding a piece of our science into this big community of science to say, hey, let's push our knowledge a little bit further. And
Mhm.
that's the thing about science. It's like you hear about some of those big breakthroughs, but to get to those big breakthroughs, you're actually incrementally working on topics for years, if not decades, if people's whole career. And we're doing a tiny slice of that, but sort of in a big way, right? We're doing it in a way that requires leveraging a lot of logistics, giving it a lot of exposure. And I think what's cool about it is that, you could do a lot of different things in a polar region, right? And certainly in the Arctic, we could have been, looking for polar bears or something like that. And that could have been the pinnacle. So the fact that we're looking for these microscopic organisms that are actually very, very beautiful if you look at them under the microscope, and giving them sort of their heyday, like sort of their like big moment, I think is so special because they're overlooked, they're underrated by most people in the world, but they're absolutely critical to marine ecosystems. They're fundamental to the Arctic ecosystem, and getting Will kind of in there looking and asking questions was really fun.
Absolutely. Well, just getting to North Pole was its own journey. I always imagine icebreaker kind of like cutting through the ice, but it actually goes on top of it and it kind of breaks it down. Like,
Yeah.
it's amazing how the ship worked, and it was so beautiful the cinematography of the episode.
Yeah.
Oh,
Oh,
that
they
was
did such a wonderful job. It's really beautiful. Like I watched the final cut of the episode. They sent me a link before we were doing some of this promotional work. And it's actually like sometimes it's hard to watch that stuff back. I don't know if other people feel this way, but I don't have that many instances of it. And when we're usually in the field doing science, we don't have anyone capturing it, right? What you have is what you remember. And so to see it play back for you compared to what you remember and like what you were paying attention to at the time, it's just very moving. Like as an
Mhm.
individual who recognizes how special it is to be there and to be able to do that type of work and in these circumstances, yeah, it's an incredible place. To be out on sea ice is a very, very special thing. It's certainly special to be out there in the central high Arctic. It doesn't get higher than the North Pole.
Yeah.
And it does require a really special ship to get there at that time of year.
Yeah. Well, talk about diving under the ice to get the samples we were talking about. I mean, it was amazing. It was like this like mountain range of like frozen light mountains under there.
Yeah. So
Amazing.
those are sea ice ridges. And basically what happens when sea ice forms, which is very different from glacial ice that forms on land from deposited snow that gets compressed and then turns into ice. Sea ice forms from frozen seawater. So you get this cycle, this annual cycle of sea ice formation in the fall and into the winter, then it grows really thick, and then it begins to melt in the summer. And so we're out there in the summertime. And what happens in the Arctic is because it's an ocean surrounded by continents, there's this constraining factor. And so, just like as you can imagine in other circumstances, if there's wind or some type of pressure pushing on that ice, it's going to fracture. And when it fractures and there's pressure on it, it creates these ridges. So basically mountains of sea ice, all those sea ice blocks you saw. And then sometimes that pressure alleviates, maybe because of the tide is changing, maybe because the storm has passed, and it goes through this cycle. And so what becomes really cool about it, which you can see from the footage, is that it creates all of this heterogeneity. So what otherwise would have looked like a flat piece of ice, like a piece of paper per se, you've crumpled it up and created all of these cracks and nooks and places that sea ice algae and phytoplankton can live. And they're somewhat protected from, say, predators, or they're protected from being washed away. And they just kind of stay suspended in those little pockets. And then they can grow really, really well when there's enough nutrients and enough light. And so that's what makes it special. And as you can imagine, giant blocks of ice are really hard to sample, especially on the surface. And we use a simple coring tool. Usually it's like a drill connected to a tube, and you cut
Mhm.
out like a column of ice. But if you're dealing with like a very heterogeneous ridge of ice that could be tens of meters thick, it's not so easy to sample the things that are living on the surface of that bottom of ice. So that's why we had to dive, basically. That's the most delicate way of collecting that type of sample from that particular habitat.
Well, visually it was amazing. I'm sure it was extremely cold in there.
So, well, yeah, that's the other thing. You get cold watching it. Like
Yeah.
you see how cold we are. You can imagine it is, it's the summertime in the Arctic, but still the air temperature on a warm day is like just above freezing. Maybe freezing is considered warm. And it was certainly minus Celsius temperatures that day. And because of the wind, because of the storm, and we're not wearing like proper gear. We're in dive gear.
Mhm.
So yeah. So yeah, things were freezing. Things were certainly chilly.
Yeah, well, thanks for what you did for our planet. Everyone can check out Pole to Pole with Will Smith, premieres January 13th on National Geographic and streams the next day on Disney Plus and Hulu. And have your social media down below so everyone can follow your journey going forward on Instagram. So thank you so
Yeah.
much for getting time to talk to me.
Yeah, thank you so much. I appreciate it.